Assalamualaikum. My name is Muhammad SHAFEEQ bin ISHAK. My metric number is A175870. I will talk about problem statement of this project and objective of this project. This project is to manage the cooling fan of the heating generating electronics such as power amplifier. For the circuit diagram, we plan to make it if the temperature rise above the predetermined point. The circuit activates a fan. When the temperature returns to normal, the fan switches off automatically. As the result, a DC fan controller that adjusts the speed level in response to temperature of the laptop is recommended to be built to solve this problem. Objective of this project is to conduct a simulation regarding the chosen electrical machine application. Secondly, to keep laptop from overheating so the laptop cannot be damaged by the overheating. Thirdly, to measure the DC fan motor speed with a desired temperature. And lastly, to get familiar with electrical machine software.
Hi, Assalamualaikum. My name is NISA binti ADZHAR with matrix number A175610, and I'm going to explain on the circuit diagram. So, the aim of this project is to design and simulate a temperature DC fan controller, where the fan can automatically be turned on and off depending on the temperature of its surrounding. Thus, a circuit diagram has been created using a software tool called Protus 8 Professional. Components used in the circuits are a 12-volt battery supply, a DC fan, resistors, a potentiometer that acts as a voltage regulator, a temperature sensor of negative temperature coefficient, and PC thermistor that is used to control the temperature, and a BC557 PNP transistor that works as a switch in the circuit. This switch works only when the temperature reaches above the preset value. It will be turned on and activating the DC fan. The circuit has been set to only activate the fan if the temperature is above the threshold value, which is 50 degrees. When the value of the temperature falls to below 50 degrees, transistors will be turned off, which will also deactivate the DC fan. As the laptop dissipates more heat, which equals to an increase in the temperature, the fan will accelerate faster.
Hi, my name is NASREEN. My metric number is A175471, and today I will explain about our mini project results and discussion, where I will simulate the schematic on Protus 8 professional software. Here is the circuit diagram to automatically switch on and control the speed of a DC fan according to the temperature. We can also control the level of temperature at which we would like our fan to rotate at. So I will explain the component of the circuit first. This is the potentiometer with 10 kilo resistance. This is the power supply, 12 volt. This is the 1K resistance. This is the PNP transistor. I use model BC557 for this circuit. Meanwhile, this is the DC fan motor, R2 470 ohms, and thermistor. The thermistor, I use NTC model, where to sense the temperature of the laptop. So we place a voltage probe across the potentiometer to measure the voltage across it. Also, we place the current probe to measure the current across the PNP transistor. Okay, so let's start our simulation with 40 degrees Celsius. So I press run. As we can see here, the DC fan is off, since we set the DC fan to be off when the temperature is below 50 degrees Celsius. Next, we set the temperature to 50 degrees Celsius. And run. As we can see here, the DC fan starts to rotate because the DC fan will rotate when the temperature is above 40 degrees Celsius. Okay, so as we can see here, when the temperature is 50 degrees Celsius, the DC fan is on, since we set the DC fan to be on when temperature is above 40 degrees Celsius. Therefore, the DC fan rotates at a low speed, which is 0.21 k RPM, which is equivalent to 210 RPM. Meanwhile, the current across the PNP transistor is 0.0424 ampere. Meanwhile, the voltage across the potentiometer is 11.18 volts. Okay, next we will change the temperature at the thermistor from 65 degrees Celsius to 80 degrees Celsius. Okay, and we will run the circuit. Okay, as we can see here, when the temperature is 80 degrees Celsius, the DC fan rotates at a high speed, which is 0.51 kilo RPM, which is equivalent to 510 RPM. Meanwhile, the base current across the PNP transistor is 0.00092 ampere, and the voltage across the potentiometer is 10.24 volts. Okay, lastly, we will run the circuit for temperature at 95 degrees Celsius. Okay, and we will run the circuit. As usual, we will wait the DC motor until it reaches at maximum speed. Okay, as we can see here, when the temperature is 95 degrees Celsius, where the laptop is too hot, the DC fan rotates at 0.57 kilo RPM, which is equivalent to 570 RPM. And the base current at the PNP transistor is 0.0021 ampere. Meanwhile, the voltage across the potentiometer is 8.97 volts. Okay, so for our overall results, we can see that when the temperature increases, the DC fan speed increases. Meanwhile, as the temperature and the DC fan increases, the voltage across the potentiometer decreases. But the base current across the PNP transistor is a little bit unstable, where sometimes the current is high and sometimes the current is low, which may be due to errors that always occur in the simulations. In addition, PNP transistor only needs a small base current for the DC fan to rotate. Thank you.
So in conclusion, rapid development of technologies involve the exclusive and expensive CPUs and GPUs that are placed inside our laptops, where they produce masses of heat. A laptop's lifespan can be diminished if it is exposed to prolonged heat, which can be very little to the laptop itself, because it can cause overheating of components or worse, damage to the PC or laptop. Thus, the laptop cooler fan is very important as it reduces the device's operating heat. Hence, our project objective has been achieved. However, in future work, it would be lovely if we could add an ultrasonic sensor that could notify us when the laptop is overheating at the moment. So it is easier to detect what applications we are using that led to the laptop's heating. Thank you.